Hello everyone. I, Dhanashree Khare and my group members are presenting on Unit 5 DSP Processors. In this presentation, we will be having introduction of DSP processors and its subtopics. Like, we will be focusing on digital signal processors introduction, what are DSPs, types of DSPs, how is its working, and then DSP's applications, characteristics and features. And then finally we will be ending this presentation with how does analog and digital signals works together. Now let's start the presentation. Introduction. Now, what are these digital signal processors? Digital signal processors are basically microprocessors. The digital signal processors take the real world signals like voice, audio, video, temperature, pressure, position, and these signals are digitalized. Digital signal processors mathematically manipulate these signals. The processors are designed to perform mathematical operations like addition, subtraction, multiplication, division, and to perform these mathematical operations quickly too. The signal to be given to the DSP processor needs to be processed so that the information they contain can be displayed, analyzed, or converted into the another type of signal that is to be used. For example, if we see a MP3 audio player, so during the recording phase, the analog audio is input through a receiver or other source. This analog signal is converted into a digital signal using analog to digital converter, and then it is passed through a DSP processor. The processor performs the MP3 encoding and saves the file into the memory. During the playback phase, the file is taken from the memory, then the DSP processor decodes the file and it is converted back into the analog signal using a digital to analog converter, so it can be output through a speaker system. So here you can basically imagine about the role of the DSP processors in any kind of system. So DSP processors can also perform some functions like voice control, equalization and user interface. Because of its characteristics like computation and high speed, the DSP can be used in a wide variety of applications like communication in broadband and wireless fields. In introduction, I have just introduced you about what could be the basic of the DSP processor and its role in any kind of system. In next slide, we will see what is actually inside a DSP processor and what is it made up of. Let's jump on the next slide. As I said, what is actually inside a digital signal processor? So, the definition is a digital signal processor is a special type of microprocessor which is fabricated on a metal oxide semiconductor with numerous integrated circuits. So, DSPs are extensively used in different applications like digital image processing, audio signal processing, sonar, radar systems, and also in consumer electronics like mobile phones. In further slides, we will also highlight some many more applications about DSP processors. So, what does DSP processors basically do? DSP is primarily used to detect errors and filter and compress analog signals in transit. It is a type of signal processing performed through a digital signal processor or a similarly capable device that can execute DSP-specific processing algorithms. Typically, DSP processor first converts an analog signal into a digital signal and then applies signal processing techniques and algorithms on it. For example, when performed on an audio signals, DSP helps reduce noise and distortion. Some of the applications of DSP processors include audio signal processing, speech recognition, biomedicine, and many more.
Till now, we have learned that in order to process the real-world data, we need to select an appropriate digital signal processor because it is necessary to determine the dynamic range and precision needed for the applications. So the digital signal processors can be divided into two categories, that is floating point processor and fixed point processor. Now in the further slides, we will be discussing each one of the processor in detail. First one is fixed point digital signal processor. It usually represents each number with minimum of 16 bits, although a different length can be used For example, Motorola manufactures a family of fixed DSP that uses 24 bits. Basically, we can say that the numbers can be represented with different patterns. Unsigned integers can store the positive values, signed integers can store the negative values, the unsigned fraction can store the levels between 0 to 1 which are equally spaced, and the signed fractions can store the values which are spread uniformly between -1 to 1. So the fixed point means the fractional point position can be assumed to be fixed. So here are some examples of the digital signal processor which uses the fixed point algorithm. So the next one is floating point digital signal processor, and it typically uses minimum of 32 bits to store each value. In floating point digital signal processor, the represented numbers are not uniformly spaced. And the architecture of floating point DSP, it is more complicated than of the fixed point DSPs because it can perform the operations of fixed point as well as the floating point DSPs. And this shark DSPs are simply designed, optimized and executed with equivalent efficiency. Here the multiplier and ALU must be able to quickly perform the floating point operation as well as the fixed point operations. As compared to the fixed point DSPs, the programs of the floating point DSPs are simple. However, they are normally expensive and the power consumption here is also very large. The types of the floating point DSPs are TMS320C67 and the series of ADI ADSP 21166.
So now further we will see how a DSP processor works. Digital signal processing is the manipulation of real-time analog signal that have to be digitalized. The analog input can be a voice, video, position or a temperature, etc. So it carries out various operations like addition, subtraction, multiplication and division on the signal to process it. The major components of DSP are program memory, data memory, compute engine, and input-output peripherals. Now we shall try to understand how a DSP processor works. So let's have a look at this block diagram. So here we have the basic 6 elements of DSP processors. As we can see, the input is taken from the microphone which produces an analog signal. The input is then provided to the signal conditioning circuitry to further increase the strength of the signal. This conditioned signal is further provided to the anti-aliasing filter. So just recall, anti-aliasing is very common term in signal processing. If we try to recall the aliasing, aliasing is the effect that cause different signals indistinguishable, which can be further cause distortion or error in reconstructing the signal. The signal is then sampled using the sample and hold circuit and then given to the further A to D converters, which converts the following continuous analog signal to the discrete time sequence, which is a digital one. Now various operations mentioned before are carried on this converted digital signal in the processing unit. After processing, the signal is then again converted to the analog using digital to analog converter D2A. This converted continuous analog signal is smoothened using smoothing filter, and then again post amplifiers are used to derive the level required for output actuators. Like here in this example, we can see it's a loudspeaker. Hence, using this algorithm, the real-time continuous analog signal is converted to digital and, processed to store. So as we saw before, that DSP converts real-time analog signal into its discrete equivalent form to perform various operations. Hence, we can say that DSP processors have wide range of application in various fields. The main function of DSP processor is to measure, compress, and filter analog signals. Usually, digital processors have better power efficiency, so they are mostly used in portable devices like mobile phones due to power utilization constraints. These processors frequently use special memory architecture to fetch data or instructions simultaneously. The major field of DSP applications are control systems, telecommunications, biomedical engineering, and AV processing, that is audio video processing.
So now we will see the characteristics of DSP. DSPs can provide the best performance, and also the memory which is used to store a program is different as compared to memory used to store the data. Next, the DSPs don't provide multitasking supported hardware. Also, there are special instructions for modulo and reverse bit addressing. DSP can be used as DMA, that is direct memory access device in the host or supporting situations. DSPs include specially designed architecture to fetch multiple data. So now we will see the features of digital signal processors. The first feature is as follows. Digital signal processors are mainly designed for supporting repetitive and numerically intensive tasks. Most digital signal processors include a powerful data path and also the capacity to move large amounts of data to memory at a great speed. These processors provide unique instruction sets to develop the efficiency of hardware. Mainly, there are two significant features of DSP. They are as follows. The first is the data path including multiple access memory architecture and fast multiply accumulate units. The second is pipelining is frequently used to enhance the processor's performance. So now we will see how analog and digital signal work together. So digital technology such as personal computers, that is PCs, assist us in many ways, that is writing the documents, spell checking and drawing. Unfortunately, the world is analog and electronic analog computers are not as versatile as digital computers. Therefore, in order to make us of the tremendous processing power that the digital technology offers us, we must do the following. First is to convert the analog signals into electrical signals using a transducer. Second, it digitize these signals, that is, convert them from analog to digital using an analog to digital converter, that is ADC. Last but not the least, thank you everyone for listening patiently.